This is a video looking at ray diagrams, particularly for refraction. What's refraction? Well, refraction is basically a phenomenon through which light bends as it moves from one medium to another. So a medium is like a substance. It could be anything, could be glass, air, water, diamond. And here's how we typically portray ray diagrams. So we typically have a boundary, okay, a horizontal line. Let's suppose we've got air up here as one medium and water down here as another medium. Okay, this is the boundary which separates them, this horizontal line. So what happens when light enters water from air? I should also mention there's a line that we typically draw for ray diagrams in refraction. It's called the normal. Normal because it's at 90 degrees. It's perpendicular to the horizontal, the boundary between the air and the water in this case. So what actually happens? Well, you've got an incident ray. So this line here, it's called the incident ray. Okay, light can be depicted by lines, straight lines. Okay, the arrow indicates the direction of travel. So in this case, it's heading towards the water. And the angle between the refracted ray and the normal, we call that theta sub I. That's called the angle of incidence. Angle of incidence. Okay, theta is used for angles all the time in maths, particularly. Okay, what happens? Well, air is actually less dense than water. Okay, water is denser. So light actually travels at different speeds in different mediums. So the refracted ray, in this case, the incident ray, it refracts, it bends towards the normal. Okay, towards this red line here, this red vertical line. And the angle between the refracted ray and the normal is called theta sub r. That's called the angle of refraction. Okay, a good analogy I always like to give to my students is that of a swimming pool. Suppose you've got two swimming pools. You've got a swimming pool full of liquid water and another swimming pool full of jelly, right? And suppose you've got two swimmers. The swimmer that's swimming in the liquid water will obviously be swimming a lot faster than the person in the jelly, okay? Think of the person as being like a light ray. So light travels faster in less dense mediums, in this case air, okay? And that's a ray diagram right there. What if we had the opposite scenario? What if we had water at the top and air at the bottom? Let's draw the scenario. Let's suppose we've got water at the top and air at the bottom. What would we see? Let me draw in the normal. That's the normal. Now, just as before, you've got an incident ray coming in. Angle of incidence is there. In this case, the refracted ray will bend away from the normal. Why would it bend away from the normal? Because the air in this case is less dense than the water. Okay, it doesn't get affected as much. So hence it continues in almost the same direction of travel. Okay, as it initially came in as the incident ray. And this angle here is the angle of refraction. So these are typical ray diagrams for the case of refraction.